Good morning, good afternoon, and good evening. Welcome back to Chapter 2. We're talking about chemical bonding. We just got done talking about how a covalent and a polar covalent bond works. Remember that a covalent bond is equal sharing. The carbons and the hydrogens share equally. A polar covalent bond, it's still sharing. It's just not very good sharing. The oxygen holds on to the electrons longer than the hydrogens do. Because it holds on to electrons longer, it gets a partial negative charge. And because the hydrogens don't get to hold on to their electrons for very long, they get a partial positive charge. It has obvious regions, obvious poles, positive poles and negative poles. That's what makes this a polar covalent bond. Here again, we see our carbon that's got these electrons it's sharing with the hydrogens. It shares 4 pairs with hydrogens, making this thing that we call methane. And here we see water, H2O. Hydrogens are sharing a pair of electrons each with oxygen. What this doesn't illustrate is the fact that the oxygen hangs on to the electrons longer. It's not an equal sharing like what we see here between carbon and hydrogen. It's an unequal sharing. The electrons stay around oxygen most of the time, and then go back around hydrogen occasionally. All right. So most of the time, if we had a stopwatch and a magic microscope where we could watch and see where the electrons went, most of the time, 45 seconds out of a minute, the electrons would be orbiting oxygen. And only 15 seconds would they be orbiting hydrogen. This is showing the slight negative charge and slight positive charge that we have in this polar covalent water molecule. It's illustrating that water is slightly negative, and that the hydrogens are slightly positive. Well, if I can have sharing and I can have unequal sharing, then I can have theft. Theft is an ionic bond. An ionic bond is a bond between ions. An ion is a charged particle. An atom with a charge means that it has an unequal number of protons and electrons. It means someone lost an electron, and it's because somebody else stole an electron. If I lose an electron, I am positive. If I gain an electron, I am negative. And I know that doesn't sound right. But I want you to imagine that electrons are like bills. So if I lose a bill, meaning I paid it off, if I make $1,000 a month and I spend $1,000 a month, how much money do I have at the end of the month? Nothing. I have 0. My bank account is neutral. If I pay off that one credit card that I've been spending $50 on a month, I lost a bill. Now what is my bank account at the end of the month? Well, it's going to be positive $50 because I used to spend $50 on that credit card every month, and now I don't have to because I paid it off. So I lost a bill, so I'm positive. Gaining an electron is like gaining a bill. If I make $1,000 a month and I spend $1,000 a month and I take on a new cell phone, I get a new contract, and this new contract is $20 more a month than I would used to be paying. Well, what's my bank account then at the end of the month? I gained a bill. I gained a new charge. So now my bank account is going to be negative because last month I made $1,000 and I spent $1,000. But this month I've made $1,000, but now I'm spending how much? $1,020. Think of electrons like bills. You gain one, you're negative. You lose one, you're positive. So an ion, as I said, is an atom or a molecule that has a charge, meaning it has an unequal number of protons as electrons. If you have lost an electron, you are positive, and you're called a cation. If you have gained an electron, you are negative, and you are therefore called an anion. The way I was taught, the way I still remember it, is anions are negative ions. Anions are negative ions. If anions are negative, then cations have to be positive. And a great example of an ionic bond is going back to the first compound that we talked about in this chapter, and that is salt. Chlorine is one of those atoms that is really close to filling its outer shell, and so it only needs one electron. It's missing one single electron, and it wants it really bad. And because it wants it really bad, it pulls really hard for that one last electron. Sodium is the opposite condition. Sodium is in the opposite situation. It has filled its inner shells, but it's opened up one new shell that needs like a dozen more electrons to be able to fill it. What are the chances it's going to be able to beg, borrow, or steal enough electrons to fill this brand new shell it just opened? And the answer is not very easy at all. There's no way it can get it all. So what would it rather do then? It would rather just give up that one extra one. It'd rather not hang on to it. So chlorine pulls very strongly for this one extra electron of sodium's, and when it does, that electron goes to chlorine. Chlorine becomes negative. Sodium becomes positive. Chlorine's outer shell is filled. Sodium's outer shell is now filled because it fell back on the one that was filled. That outer shell that it had just opened, it basically just gave it up. It's kind of a lot like collecting trading cards. Like if you collect baseball cards, you want to have all of the cards of a particular season. Imagine that you collect, 2016. And so you want to get all the cards for the 2016 season. And you have all but one. What happens, or rather, how bad do you want that one card? And the answer is you want that one card really bad. Well, your friend also collects baseball cards, but he collects 2018 and 2019. And his aunt knows that he collects baseball cards and just gave him a pack of 2016 cards. Thanks, Auntie. He opens that pack, and in that pack is that one card you need. How bad does he really want to keep that one card for a set he doesn't even collect? And the answer is not very bad. But it's still a gift, and so he can't just give it away. He doesn't want to just give it away. How bad do you want that one last card to finish your set? And the answer is really bad. All right. You want it really bad. So, yoink. Now your set is filled. Your buddy falls back on his filled sets. Everybody's happy. Not exactly happy, but happy enough. Now that chlorine is negative and sodium is positive, what do opposites do? Opposites attract, and because opposites attract, then sodium and chlorine are attracted to each other, and they make this stuff that we call salt. Our three kinds of bonds are covalent, equal sharing, polar covalent, unequal sharing, and ionic theft. There is a fourth kind of, it's called the hydrogen bond, but I think calling it a bond is actually, if you compare it against the strength of the three we just talked about, then it's not a bond. It's an interaction, and it's a strong enough interaction. It actually causes water to be really weird. But I wouldn't go so far as to call it a bond. It's called a hydrogen bond. And a hydrogen bond is between the weak positives and negatives that you have on polar covalent molecules. Polar covalent molecules like water. Are you ever just going to have one water molecule? And the answer is no. I'm going to always have dozens of water molecules. Well, what is the partial positive on a second water molecule going to do when it encounters the partial negative on an oxygen? It's going to be attracted to it. And they'll kind of be connected to each other, kind of similar to magnets. Kind of be like magnetically, but it's charged, not magnets. Kind of magnetically attracted to one another. The same thing with another oxygen is partially negative is going to be attracted to the positive on this hydrogen. All right? This is called a hydrogen bond. And it's what gives water a lot of its weird properties.